Bismillah ar-Rahman ar-Rahim. In this session, we will discuss the physics MCQs paper, version 11 from May June 2024, question number 11 to 20. So, in this session, we will discuss question 11 to 20 from the multiple choice questions. Here we have the first questions. A student of mass 60 kg climbs some step like this. He travels a horizontal distance of 2 meters. This is a horizontal distance, and a vertical distance, that is 1.5 meter here. So this is all about the definition of this problem. What is the work done against the force of gravity? What is the work done against the force of gravity? Force of gravity acts downward. So we have any force that moves against the gravity force is the work done against the gravity force. So here we have, so this is the change in height from this level to this level. So we will take this vertical distance 1.5 meter, and mass is 60 kg, and the acceleration due to gravity is 9.8 newtons per kilogram, or 9.8 meters per second per second. So this is work done against the force of gravity is given as weight into distance in the direction of force. So weight is equal to mass into gravity. So weight is 60 kg into 9.8 meters per second, and the distance of the in the direction of force is 1.5 meters, and when we multiply all, we will get this 882 joules. So the nearest answer is option C, 880 joules. So this part, option C, is correct. Now question number 12. Which method of producing electricity does not involve a turbine? Turbine is a rotating part. So we see that hydroelectric station has a rotating turbine, nuclear power station steam turbine. So turbine is there also. While in a solar cell, we see in a domestic level that there is no turbine. So this option C is correct. Wind generators are rotating parts. We see the fans or fins in a wind turbine, in a wind generator. So turbine is everywhere except solar cell. So this option C is correct. Question number 13. The input power to a lamp is 6 watt. Okay. The lamp wastes 2.7 joules of energy in 3 seconds. In 3 seconds, the waste is 2.7 joules. So what is the efficiency of the lamp? So efficiency is obtained as output energy divided by input energy. So input energy is for 3 seconds, 6 watt into 3 seconds is equal to 18 joules. So the input energy is 18 joules, and out of this 18 joules, the energy waste is 2.7. So 18 minus 2.7 is equal to 15.3 joules. So the output energy is 15.3 joules, while the input energy is 18 joules. So 50 upon 3 divided by 18 is the efficiency. So the option D is correct, 0.85. So output energy divided by input energy is 0.85, and efficiency is obtained as output energy divided by input energy, and output energy is basically the input energy minus loss divided by input energy, and that is 0.85. Now question number 14. Camera is taken underwater and left at a depth of 8 meters. Underwater, camera is taken underwater and left it at a depth of 8 meters. 8 meter at from the surface of the water, it is inside 8 meters depth, at the 8-meter depth. So the atmospheric pressure is 1000 Pascal is given, and the density of the water is 1000 kilogram per meter cube. This is the density of the water. This is also given. What is the total pressure acting on the camera is asked. So we see this delta P is this 1000 kilograms per meter cube, and rho GH. This is rho is basically the density of the water, 1000 kilograms per meter cube. G is the gravitational field, or this is 9.8 newtons per kilogram, and this delta H is the height, depth from the surface of water to the depth of where the camera is placed is 8 meter. So this is delta H is 8 meters, and when we multiply we will have this 78400 Pascal. Well, the atmospheric pressure is 100,000. So we'll add 100,000 with this pressure. So the total pressure is atmospheric pressure plus this delta P, which is 78440. So 100,000 plus 78400 Pascal is equal to 178,400 Pascal, and we see this 178,000 is very close to it. So option D is a correct option. So 14, from question number 14, the camera will bear this much pressure at the depth of this 8 meters. This much pressure, total pressure. This is total pressure is been asked. If they ask the gauge pressure, then this answer is sufficient. Gauge pressure is this, but if somebody asks the total pressure, then we have to add this atmospheric pressure to this delta P. That's why atmospheric pressure plus delta P is this. So question number 14. Now question number 15. In which examples are the particle is in fixed positions? In a solid, the particles are always in a fixed position or move in its own position, back and forth. So ice in an ice cube is the option, and we can learn in a detail from the state of matters, the topic state of matters. So ice is a solid structure, and in a cube the neighboring atoms or molecules will knock each other, while in water, in a lake, the water molecules are free to move. Air in air bubbles are also easy to move. Water vapors in atmosphere are very freely moved. So ice in ice is the best option, and this is option A. So option A is correct. A gas expands slowly and its temperature remains constant. Gas expands. It means the volume is increasing and its temperature remains constant. Volume expands means pressure is decreasing. A gas expands slowly and its temperature remains constant. What happened to the gas particles? So the first option is they move further apart and their average speed decreases. Average speed, here the temperature will decrease. If average speed decreases, means temperature, kinetic energy is decreasing. Kinetic energy decreasing means temperature is decreasing. So while the temperature is remains constant, so this option is incorrect. They move further apart and their average speed increases. If average speed increases, the temperature will rise. So this option is again incorrect. They move further apart and their average speed remains unchanged. So they move further apart. So when they expand, their molecules have a more distance and their average speed remains unchanged. So speed remains constant, means temperature is constant. So this option C is correct. They say that same distance apart and their average speed decreases. No, because if they occupy the same distance, then there will be no expansion. So this option D is also incorrect. So option C is also only option C is correct, because they move further apart because the gas is expanding. So more volume will be there, the pressure will decrease, and the temperature will remain constant. And this is also called the Boyle's law. 17, question number 17. The air in each 4 syringes is slowly compressed. In a syringe, the air is we take the syringe in a medical store, like we see in a various clinic or in a laboratories. A syringe is there and it is slowly compressed so that the temperature of the air stays constant. The volume before and after compression of each syringe are given in the table. So the air in all 4 syringes is initially at the same pressure. The pressure was constant in all syringes. Which syringe shows the smallest pressure change? Initially the pressure or air in all 4 syringes is initially at the same pressure. So this A, we have given the volume before compression and after compression. So from 50 it decreases to 40 cubic meter, from 100 cubic meter to 50 cubic meter, 400 cubic meter to 25 cubic meter, 400 cubic meter to 100 cubic meter. So this is volume 1 and this is volume 2. So we know the Boyle's law is P2 V2 is equal to P1 V1. So P2 is equal to P1 V1 upon V2. So here we have P1 and V1 is 50 and V2 is 10. So the ratio is 5P1. Here we have 150 and this is 2P. 400 divided by 25 is 16P1 and this is 400 divided by 100 is 4P1. We can see that P2 is 4P1, P2 is 2P1, P2 is equal to 16P1 and P2 is equal to 4P1. So here we can see that from P1 is all constant here as given in the problem. So we see that the pressure change is very small here in this option B. So the correct answer is option B. Now question number 18. The temperature of substance is measured in a liquid in a glass thermometer. Which physical property changes so that the temperature can be measured? So we know whenever we expand a liquid, it expands, it always expands. So the physical property that changes in a liquid in a glass thermometer to measure temperature is a thermal expansion. So when a liquid in a glass thermometer is heated, the liquid expands and moves up in narrow tube, like in a thermometer. When a liquid is cooled, it contracts and moves back down the tube. The level of the liquid in the tube corresponds to the temperature on the scale. So which property changes so that the temperature can be measured? It's volume of the liquid. It will expand, so the volume will increase. The volume of the liquid will show the temperature change. So if we cool the temperature, the liquid volume will decrease. If we heat the temperature, we rise the temperature. Then if we raise the temperature, then then volume will increase. If we uh, lower the temperature, then volume will decrease. So the change will appear in the volume of the liquid. Mass of the liquid will remain constant, length of the thermometer will remain constant, specific it will never be changed. So option D is correct. Boiling and evaporation are two different processes. Which statement is correct? We know that evaporation occurs at the surface of the liquid, whereas the boiling occurs throughout the body of the liquid. So this option A, boiling occurs only at the surface of the liquid. No, boiling occurs everywhere of the liquid. Every body of the liquid occurs throughout the body of the liquid. So this option is incorrect. Evaporation only occurs when the temperature of the liquid is high enough. No. So evaporation only occurs when the temperature of the liquid is high enough. Evaporation occurs at every temperature. Definitely that with a rise in temperature, the evaporation rate will high. Evaporation does not change the temperature of the temperature of a liquid. Definitely when a high temperature molecules escape from the liquid, the temperature of the remaining liquid will definitely cool down. But this is not correct. Option D is also not correct, because the evaporation does not change the temperature of the liquid. It will change the temperature of the liquid, because the high excited molecules of the liquid will escape. So the average temperature will decrease. When a boiling liquid is heated, its temperature remains constant. Yes, this is correct. When a boiling liquid is heated, its temperature remains constant, because temperature will not rise during the boiling. Evaporation occurs when a range of temperature, whereas the boiling occurs only at a fixed temperature. Boiling occurs at a fixed temperature. Evaporation occurs over a wide range of temperature. So over a wide range, evaporation always occurs from very low temperature to a very high temperature, but boiling occurs at a very fixed temperature. Temperature decreases as a result of evaporation. Temperature decreases as a result of evaporation, because the liquid molecule at the surface gets some minimum kinetic energy to escape, lowering the temperature of the liquid. So all the details about this question number 19 is given. So there are many other questions can be answered if we know all these details. So so all the details have been gathered here, or collected here, or compiled here for the best understanding of the students. Now question number 20. A glass breaker contains water. This glass beaker contains water when the center of the base of the beaker is heated. Here the beaker is heated at the center. A convection current is set up like this. This current is set up like this. So this convection current, which statement is explain this? The evaporation of water causes water molecules to rise to the surface. Evaporation of the water causes water molecule to rise to the surface. No. Second, the expansion of the water molecule causes them to rise to the surface. Expansion of the water molecules causes them to rise to the surface. No. The water above the heat source is rises because it becomes less dense. So when the temperature rise here, it becomes less dense and goes up, and from the surface the temperature it reject heats here and it cool down and it will come back to the bottom. So this is called convection current, and as a result of this convection current, this is established. This convection current is set up. So this option C, the water above the heat source rises because it becomes less dense, is the correct option. The water at the side wall becomes falls because it becomes less dense. No, this is not correct. This one is correct. So this option C is correct. In the next session we will discuss from question number 21.